Hello. Alright. I believe we are live. Let's just go on YouTube to double check that I am actually live. It's more Stephen on. Okay, so we are live. Again, since last time, it's been a bit of time. I'm not going to give excuses, but let's just analyze why I haven't streamed in a long time. Okay, there's like 2-3 reasons. The first reason is that my MacBook, okay, let me close this. My MacBook got cooked. Wait. Oh, you know what I can do? Let me make a new scene. And let me copy this. Okay. Oh, okay. Now you can see my face. Alright, the first reason why I was not able to stream is because my MacBook got cooked. I spilled Red Bull on my MacBook, so I couldn't stream anymore from my MacBook. I was traveling for a bit of time, but actually I've streamed since coming back from China, so that's not the reason. And I haven't been waking up like super early. So it is currently 11:53 p.m. and that is when I started streaming. So I want to get back into waking up earlier again, which is easier said than done, right? Again, I need to remind myself that habits. You need to sort of like start doing something, and over time you build this habit. Like, it doesn't just come overnight. Oh yeah, the main reason actually. Well, I've been working on some things. And I was like, this is not worthwhile to stream, so I just did not stream it. This is kind of stupid. I don't know if it's worth my time to do this, but I thought it would be cool to kind of learn about it, which is looking at financial data and trying to predict the market. I know it's very cliche, and I'm even cringing a little bit saying that I'm doing this because I don't know. I just always thought that there's not much alpha there in terms of trying to predict the market. You should just buy and hold, right? But I met someone 2 weeks ago, and she told me about how she was able to do it, and it didn't seem like it was that much harder. And so meeting her made me sort of convince her, or at least want to try to build my own models and try to predict the market. And so I've been spending the last week just trying to build my own sort of algo trading stuff. And I'm screen sharing this stuff because right now it's not that good. If it actually worked and made money, I would probably not share this, right? But I do want to document what I've tried, and I'll be honest, a lot of this is just vibe coded, because here I'm not actually prioritizing code. I'm not optimizing for code necessarily. I just want to produce something, and most of this is just setting up a data set. And I know sort of what's going on. There are some details that might go over my head, but as I look into the code more, I'll sort of figure it out. So the main thing I want to show first of all is what I've tried, and I think by speaking to what I've tried, it can also reinforce my understanding of this. So let me walk you through what I've tried so far. The first thing I tried was looking at something called an order book, right? So if you go on Coinbase, or this is crypto, it doesn't have to be crypto. Live price. Actually, yeah, we can go on TradingView, and let me just make sure flow chart. I actually don't know how to use this that well. The stock market's open right now, is it? Okay, let's say object data window. I don't know how to. I saw it on trade. Wait. How do I see the order book? how do I open this?
Imagine being able to build an app with your name.
Today, we will show, how much volume
It might not be a feature on TradingView.
to our trading, at least.
Because I did see it on... Okay. It's essentially something like this. Yeah, perhaps I need to get better at like visually explaining this stuff. And order book... Oh, is it here?
Hey there, so in this video,
Okay, this is on Binance. Okay, Binance, Bitcoin, price. I might need to be logged in to see this order book. And I don't want to log in live on stream right now.
I'm going to be talking about
Yeah, Bitcoin, trade spot. Okay, oh, you can see it. Alright, so this is like the price of Bitcoin, right? And this is the order book. So when people want to buy this asset, people will place orders for buying and selling. So these are the sellers, and these are the buyers, right? So the sellers always want to sell it at the highest price, and the buyers want to buy at the lowest price, right? And if the threshold is crossed, then you can actually fill an order. Or if someone's willing to buy one of these, or if a seller is willing to accept that they're gonna sell it for a lower price, then an order gets filled. And so wait, I'm being stupid because I'm not even sharing my screen. Okay, this is the order book, as I was saying. And oh, by the way, I am streaming on my Ubuntu computer now because my MacBook is cooked. And so this Ubuntu computer sometimes freezes randomly. There's nothing I can do about that. But it's been okay so far. I just hope that it doesn't freeze on stream. Okay, so what was I saying? The order book, right? You have sellers and you have buyers, and if the buyers always want to buy it at a cheaper price than whatever the sellers want to go for. And if any of these cross, then an order gets filled, right? So if I'm trying to buy and I am willing to buy at a higher price, like right now it seems to be at 65,820, then an order gets executed, right? So this is spot trading. There's like margin trading, and I actually don't really know what the margin trading and the option trading. I try to understand it, but let's just say we're dealing with margin trading right now, and you have this order book. So my intuition was like, when you look at people who trade stocks, like usually, okay, let me pull up like TradingView right here, right? My intuition was like, most people, they trade based on, just purely looking at these bar charts, or these are called candles. Okay, and I quickly learned how to read candles. Basically, when you read candles, you have sort of like 4 things you're looking at. So this filled bar, this will tell you the open and closing price, and these lines will tell you sort of like the highest price and the lowest price that it has reached in this time frame. It is different from like the quartile charts, because I originally thought it was like bottom 25%, mid 50%, top 25%, but it's actually not how that works. And if you're not sure what I'm talking about, I was thinking of interquartile range plot. Okay, and do I have a note for this? Yeah, I was thinking of like interquartile to be confused with let's close this. High, open, close. Yeah. This is basically how you read it. It's not that complicated. Anyways, I learned how to read candles, but people usually, from my understanding, try to trade the market based on these indicators. For example, technical is like what's RSI, that's the relative strength index. I believe these are just to me they were like just derived from these stock prices, right? And so you have things like a moving average. I don't really know how RSI works actually. Calculation, let's see, average gain and average loss. Okay, it's a momentum. Okay, so it calculates the momentum. So yeah, it takes the price, takes its, you know, if it's gaining or losing, which are all just purely derived from these stock prices, and then it calculates some running average of it, right? And of course, like, because it's taking past values, it's always going to be some lagging indicator, right? So if you look at, let's do like moving average, right? Like you have oh, you can tell I don't know how to use TradingView. What is this? Okay, yeah, you see the moving average here. Alright, so it's just going to take the stock prices and it's going to compute a moving average, and then you can specify some sort of window. I don't know where you specify that. Again, I'm not a stock trading expert. I just like stumbled upon this. Oh, okay, anyways, I don't want to spend too much time on this stuff, but I'm okay explaining my idea. And so we would look at the, I was thinking there was more alpha to be extracted from an order book, right? Because if you look at your order book, you can actually sort of like, there's like hidden information that you don't get from just looking at your chart, right? Because if you just look at your chart, you can just see, oh, there's more, okay, open here and closed here, and what was the volatility within this region. And you can, okay, you can get information such as, so these represent the volume, so the more the volume, the more trades are executed within that time period. But this this information doesn't capture sort of like how like trades are actually executed during that time period, right? So I was thinking, because in the order book you can actually see like how deep the order book is. There like a concentration of like orders at a given price and how much of them, so you can sort of see the buying and selling pressure more accurately. And so if you can model that relationship, then you can you know, you can try and predict the stock price more accurately over time. And so I sort of like vibe coded, I chose like an asset, and you know, I downloaded the order books, and then I was like trying to predict the next price based on that. So I think like my order book, so like I have a collector script that collects the order book, and then I have a limit order book data set. Okay, and then this is like a data set that loads a data frame. Again, it's not optimized. It's all like, oh, it's okay. It's an independent data frame. If you want to get it for training, you're gonna move it as a torch answer to your actual device. Yeah, a lot of this needs to be optimized. And in the second part of the stream, I will try and optimize. I want to do something different, which is like what I was doing the last 2 weeks, which is like GPU optimization, and I'll show you guys some really cool stuff that I learned about that I want to learn more about. But for now, I want to finish going over what I've done here, and so that if I look back on this next time, I can sort of like remind myself what I did. So you can load data, and then I store the data in a Parquet file, which is a file format that's more compacted or more efficient. It's a lot of people use it. I actually don't know if it's more compact or more efficient. It's column oriented, and it's efficient. It's efficient. It's good for storing columnar data, and it's more efficient. It stores it more efficiently. How does it store more efficiently? I assume there's some sort of encoding, but I should know this. It does bit packing. I learned this stuff. Wait, did I not like? I learned this in my CS class. And I guess we just use the file format, but okay, they use these two strategies, but dictionary encoding, interesting. What is bit packing? Okay, they actually pack things in a bit, and run length encoding. Yeah, if you see a value multiple times, instead of repeatedly storing that value, you can just say the number of times you see it. Dictionary encoding sounds interesting though. Doesn't that sound like run length encoding? Oh, what? Okay, turns out I had a note on this. Serendipity. Okay, sorry, we're deviating real quick because I don't know about run length encoding, so I want to write a note real quick about this. Okay. Okay, it's very similar. It's very similar. Run length encoding, except that we the data doesn't have to be looking at the instead of the repeated chunks. I need to get better at like expressing ideas more succinctly. Like see how I'm trying here to explain with this. The data doesn't have to be continuous. It's looking at the entire data that we're trying to compress and find those that we can avoid repeating by starting to look at the table. Or you can just say the repeated chunks can be anywhere. Like that's all you want to say, right? Like you have to be more laconic. Okay, so we have dictionary encoding. Alright, run length encoding, and then we have parquet files. Okay, bit packing. Bit packing is like not that complicated. Yeah, I guess like okay, let's make a note on bit packing. but let's look. Let's ask chat, because I believe that bitpacking, you know, if you actually store the data, so if you already know that you can read at a certain offset without having to do the bit shift, like it can actually, it's way faster. Yeah, cache miss is more expensive than copy build. Let's say it's just a struct. It's we spend a byte. Is it we bitpack it? We have a bool, which is a byte. If we did a 3-bit element instead, okay, assuming single threaded, right? Your writes have contention, no? Like you need to build the thing. So you're just writing. I mean, you're still writing with an offset. Like I'm trying to see which, if it's slower or faster. I'm not sure about this one, guys. If it's yeah, this is spanning 3 bytes, but because yeah, you just store a bit shift. Or this equals A, B, C, this is test type. So yeah, 3 writes versus 1 write. In this case, you're writing C to some temporary variable and then B to some temporary variable, and then you're doing an OR with them, and then you're also writing this to memory. Like, what I'm saying is, like, these write to memory. So what's swing? Like this looks like more writes. There's no computation, right? So is it true to say that I don't think it's true to say that it's less write intensive. But you can see that, you know, like one and like A, B, C. No, I swear, wait. Because you're eliminating the memory bandwidth, right? You're sort of like loading much smaller arrays, but during your computation, you need to use your registers to do bit shifts. in this case, if oops. Is that even true? don't remember this. Like when you so it doesn't carry. L2 is also. Yeah, you can pin a core to that thread. In which case it will not exist in the L1 or L2 cache, it will be there in the L3 cache, and you just need to load it again. And every time you make an entry, it will invalidate the cache entry at any other place. Okay. So the trade-off is like when is Bitpacking bad? I think like the overhead of yeah, I guess like you can bitpack like a 32-bit element with an 8-bit element. But it will be aligned in the largest member. So if it's 4 bytes, then everything will be 4-byte aligned. And the reason for that is just if you want to read an element at its offset, you want to make sure that is actually safe. Right, because basically each element, let's say it's a 4-byte element, then it should be at an address that is a multiple of 4. And if you don't have that, then you're going to end up busting your model. Well, the struct needs to be. Is the struct? The struct needs to be a multiple of the size of its largest member, but then each member within the struct. Oh my god, I can't believe I'm forgetting this. It's just basic memory alignment. So in this case, I suppose so every element needs to be aligned to 8 bytes in this example, right? I guess each element needs to start at a multiple. So that's, it's not that A needs to be 8, it's that the next element needs to be, sorry, so like if you had 5 and then 2, it actually starts at memory address 6. So 5 bytes 5 to 6 is just wasted. Okay, sorry, I remember now. Okay, so yeah, what am I doing? Why am I going down this rabbit hole? We're trying to understand when bit packing is bad. So when we have vector instructions, you can vectorize it more nicely. Yeah, you can still vectorize it where you just add up these elements and then you apply bit mask. Yeah, I don't think it should be too hard. Like if you're doing a vector add on 2 registers, but only those bits you care about, you just add the whole thing, but you add a bit mask. Anyways, yeah, bit packing. All this to talk about Parquet files. Okay, cool. But we learned something new. We learned that what the idea behind bit packing is, and to capture the idea consistently is that instead of storing bytes, sometimes we can compact the data more by storing it at a bit level, and then we will need to do bit manipulation. Is if we compact a struct not respect Okay, let's write a no click on this. I don't understand the sentence. Data with a small, for data with a small, what data is a small name? Like, does the dictionary? I don't understand this. Does the dictionary have a small number of unique values, or the data has? This is why English sucks, man. How can data have a? I see. Cardinality. She was 105. I see. It's always columnar, right? Isn't there a delta encoding? Wait, let me look up something. Byte encoding. These are all like compression, right? Okay. Huffman coding. Bit packing. Arithmetic encoding. Delta coding. Wait. This is actually interesting. Wait, image compression. Piecewise linear compression. Yeah, but this is lossful compression. I guess that's like. Yeah, I did Fourier image compression. Run length encode. I think this is better named run length encode. Rename. And there's dictionary encoding. Okay, are these on the main one? yeah, I mean, okay. Alright, that's like cool, deep compression. Encoding, delta encoding. Lossful would be just like Fourier transforms. Okay, cool. Alright, so back to our notebook finally. We're using Parquet files, we're storing it, it's very efficient. It stores it in, it cuts down the rows, then it stores particular columns, and the columns are broken down into pages. It's much more efficient at storing these columnar data. And so initially I vibe coded this, you know, loading this order book, you have some price, and I was trying to build a predictive model to predict the price of a given stock so that we can make decisions on whether it's going to go up or go down. But the issue is with these order books is that it's kind of hard to backtest. In particular, I saw this video of how they did these permutation tests. So maybe I'll just go to the candlestick version, because what is happening when you do these permutation tests is we want to sanity check that the price we want to sanity check that okay, I just saw a comment. Okay, I usually never look at comments, but I'll answer your question in a second. The point of this permutation test is that we essentially want to sanity check that the pattern that we've learned is not just purely from like luck or chance, right? And so if you were to permute your data, you should see a degradation in your algorithm, right? So if there's no degradation in your algorithm, that just means that this pattern that you saw was probably just out of luck because it works for any random pattern with your data being permuted. And so this is sort of the result. And as you can clearly see, like, first of all, this is plotting the return of my strategy, and it's not going up, so we're actually losing money with the strategy. And this is what a permutation would look like for a given stock. So when we're doing the permutation, we're not actually permuting the price, we're permuting the returns. which basically means the delta between the current time step and the next time step. So the reason we do that is because if we were just to permute the price, it's going to be super random. Like you can imagine like a stock price is like, imagine a stock price like goes up over time. If you just permute it, it ends up being very like up and down and zigzaggy. So that's not what we want. We want to actually capture the, you know, jumps, or like the derivative of the stock, like the first order derivative of the stock, that is like how it changes over time. And so this is what we do. So that's why like the stock price generally starts at the same, it all starts at the same price, but the jumps are going to be different, and the endpoint is also the same, because the sum of these deviations, no matter the permutation, will be the same at the end. So the starting and end point are the same, but you're sort of like changing what is in between. And then you can see sort of like if we apply our strategy for all of these different stock prices and we look at their decisions, would we get a stronger or weaker return? So what we want to see is that the stock price is the highest over here, like the return of our strategy, which is in red on the original one, should perform the best, and it does in this case, but I don't think it's statistically significant enough, and also it actually loses us money. So the first, yeah, this is sort of where I'm at. It's like, it's kind of hard to make an actual winning strategy, and if you look at the actual price of the stocks, like this is like a cryptocurrency that I'm taking. Okay, it is going down, right? The stock price is going down, but if you have a really good model, it could actually you know, long here, and then it should sell off here, and it should not even buy in here. It should like buy here, sell at the high point, etc., right? But obviously it's very hard. And the model I used for this candlestick one, so I gave up on like doing order books, just because, you know, it's not clear how you do permutation tests with an order book. Like usually you just work with candlestick data, because you have the price and you have the returns, and then you just feed in these prices into your model. But if you were to do like order book, like if you permute a order book, it doesn't really make sense. So I didn't really know how to make permutation tests with order books, and I think order books are also harder to get right. There's more complexity and more noise in the order book, because there's way more data. And so I decided to go with like doing financial, or just like candlestick at first. But yeah, this is sort of like where I'm at in my experimentation. I you know, in terms of how you set up this how you set up your testing and your strategy, from what I learned, is like you load your data, right? You want to make sure you don't pollute your training and test set. Like it's very easy with these time series data to have leakage, so you want to make sure that your training and testing set do not overlap at all, and there's no way you can have like future information baked into your training data. And the next thing I did was like doing a forward walk split, and this just basically means that I'm actually going to train the model multiple times over different time intervals, because with financial data you end up with like lots of distribution shift, right? So a pattern that exists in one particular time step will not apply to might not work for the next next time period, and so you might need to end up like retraining your model at multiple times. And so in this case, I'm just sort of like trying out, okay, does this architecture work in terms of like learning the pattern? So if we train on 90 days and then we try to predict the next 30 or 28 days, so 14 days used for validation and 14 days used for testing, how well does the model do, right? Assuming it's only been trained on like, yeah, these 90 days. And so this is what I do here. And so you have like multiple folds, and each of these folds you can visualize the performance. So I think if I plot it here, here there's only 2 folds, because my actually, let's just run this, like it's gonna take a bit longer. Okay, let's do 2024 to 2026. So it loads the data and loads all these Parquet files, and then it does the training here, and you'll see there's going to be way more folds. Yeah, and in terms of the model here, yeah, like before you even think of the model, I think it's important to think of like the setup for the problem, right? So I actually don't think the model matters as much right now as like your setup. I think the setup is really important, because there's this saying like, if you have garbage in, and it's garbage out. So you want to make sure that, you know, what, like fundamentally what is the data that we're feeding in, right? You only have like candlestick data, basically, is what this model is. Because I also was playing around with like different features that we could pass in, like derived features, but yeah, I tried a bunch of different sort of like parameters and like so if I can show you guys real quick, like these are some of the features. So you have your log return. You don't want to give in the price because price suffers from distribution shift, right? But if you use return, that's something that's going to be more constant and stable over time. And then range and body. Okay, to be honest, some of these are like, I asked chat to give me some features, but these are all just derived from the price, so I don't think they're that much more informative. But because you apply transformations over your original data, it might make it easier for your model to learn from those like transform features, right? Similar to how like I was seeing like if you have like a neural net learn sine over 1x, right? This very like complex or very oscillatory function when it's close to 0, right? This is like something fundamentally that a neural net struggles with if you just give it like different sine of 1x, like or like if you give it different x's and then have it try to predict sine of 1 over 1x. But if you change your representation to be 1 over x, right, then it becomes really easy for your model to learn, because then it will just learn sine. It will only have to learn sine over x, right? So or sine of x. So if you provide as an input 1 over x as opposed to just x, then it becomes a lot easier for your model. So representation matters a lot in that sense. And then you make your model decisions based on what is, you know, what are your constraints, what is the problem that you're trying to learn, right? Because like if it's just a linear model, you just use linear regression. And okay, I think that's what I wanted to cover for the financial modeling. These are my results. I think I'm still going to take a stab at this a little bit more, but yeah, you can see here like, okay, in this case the majority class is 85%, so like that is our baseline. Okay, this is like, my alpha is like kind of like too high. In this model, so I think one mistake that I'm making is like, what is the model having to predict? And I think having it just predicting, right now in this setup, I'm having it predict price movement, so up, down, or the same, and I'm setting a threshold for what do I consider price stayed the same, right? So it's like doing a 3-class, it's like doing classification on 3 classes, and I'm using a decision tree. And then you can see here where are the different decisions. So I have a backtesting engine afterwards to simulate what we would do. So given our model tells us is the price going to go up, down, or stay the same, and we will either buy or sell a stock. And currently in my backtesting, I'm only doing a long based strategy, so I'm not shorting a stock, just because shorting a stock, it can have like infinite downside, right? If the stock goes up, I need to like pay the price of the stock, whereas if you're longing a stock and it goes to 0, the most you can lose is like the price you put in, right? But like shorting a stock can have infinite downside if like the stock shoots up like a lot, right? And okay, this is just like my equity curve, etc. Okay, this doesn't really matter. I think that the main thing is I tried this. The next thing I'm gonna try is this triple barrier method. So I found this book. Anyways, I'm not going to do it in this stream because I have to actually go as well. And I'm sad I didn't get to do performance profiling today because I've spent some time doing lucky into compression. And then I'll answer your question as the last as the last thing. But this triple barrier method is essentially, instead of like doing this classification of like whether it goes up or down or stays the same, you actually want to predict like what is going to happen to your stock. So you actually set a take profit barrier. You actually set 3 barriers: the take profit barrier, the stop loss barrier, and I guess your entry price. Oh, a vertical barrier. Okay, on the timeline, which is our exit trade no matter what. Yeah, okay, I don't know why it's called a Spielberg. Actually, I didn't read to this. My intuition on like how this works without reading too much into it, but I was gonna read into this. Uh, it came from a book, and this seems like a better way to approach like using ML models to, for financial machine learning, for finance basically. So I was gonna try this and see if this works better, but I still feel like there's not enough alpha for me to extract at the current moment. I might need to have like more privileged information. But this is like another thing. Anyways, I was like reading a bunch of like, watching a bunch of videos, reading a bunch of articles, and there's like some people arguing, like, because once you start increasing the number of features, you end up like overfitting way more and more, and how well it can generalize to future stock prices is not really clear to me. Like, once you have like so much more moving pieces, it becomes really hard and annoying to debug and to validate and test. So I like to always start simple, right, and like get a really good intuition of like what it takes, right? So yeah, this is just like the beginning of the journey of this. I thought it was gonna be easier to make money. Like at this point, like I thought it was like I was able to, like, I think, I can train a model that basically learns this pattern and basically memorizes it, but it doesn't have really good predictive power over like the future stock price. So that is expected, because if you were able to do it, then you would have like a lot of alpha, right? But I'm gonna keep trying a bit more. I'm gonna stick to the decision trees because those are like the simplest models. I'm gonna try a different representation for like what the model should predict. And the next thing I wanted to show was like performance tuning. I was gonna show you guys NVIDIA Insight Systems because I wanted to get better at profiling, and I spent some time. Actually, you can see it here. So I want to spend some time and like look into these traces, but yeah, unfortunately I need to head out very, very soon. So I'm gonna answer the question in the chat here. If you want to maximize yourself in ML and data science field, how can you do that? I think like you just need to spend more time doing the thing, right? You need to be hyper obsessed. If you want to be the best at anything, you need to spend the time, and what that means is every day you try to learn as much as possible, like what I'm trying to do, right, in a particular field. Write notes, learn as much as you can, be very, very curious, and you can also participate. I don't know if like Kaggle competitions are still the best, but you can do Kaggle competitions if that's what you're passionate about. I think competing is a really fun way to like challenge yourself and push yourself and see if you can, be the very best at this thing, and there's something to strive for, rather than just like working on projects on your own, which sometimes it's like you don't know like if anyone's like it's harder to be self-motivated by like your own projects, right? So for me, it's like when I work on a project, like I think of like, oh, can I make a video, or like can I share this with the world, or like that's partially also why I stream, although I stream for myself too. It's just like being able to look back on things. But yeah, I think that's my high level advice. I think I heard this from Karpathy. It's like too many people want to, or is it in robotics? I think I wrote it in robotics. Too many people worry about how you get started. It just matters that you start somewhere. Beginners are too focused on what to do and not how much to do. So you just need to do more of it, and then you'll get better over time. Anyways, that is my advice. I really want to get back, learn the performance tuning, and I really just want to make more stuff, man, and share more, because I do realize, as I reflected, like, I enjoy sharing and teaching and inspiring people. I also want to keep improving and keep striving, but there's always this mental block of like putting things out there and editing, and somehow like over the past year or two, like there's just this dread of like, this thing is gonna take so much time, and I don't want to work on it because it takes so much time, you know. And it's like, oh, it seems like the ROI is not there, right? And when you're younger, you are blinded by this optimism where you're like, okay, it's not gonna be that hard, so you just do it, and then you just didn't anticipate how hard it would be. I think like Jensen Huang also said the same thing about like starting a company. Like if you knew how hard it is, like you wouldn't do it in the first place. And I feel like I'm at a point where like in many things it's like there's like the dread of like how much work it's gonna take and like the ROI not paying off, and I still have like this mental hurdle of like not knowing, you know, how like not like I basically need to do it even if I know the reward's not gonna pay off. Actually, no, that's stupid. I think like you should do things if the reward pays off, but I need to find a way to do things because yeah, basically it's like, okay, the reward doesn't pay off, so I just rather not do anything, right? And so, but like that's not good. Like you should not do nothing. Like you should find something where the reward pays off. And I do think like making content and like things like that, like there is like I've gotten so many good things from that, and yet you know, I don't do it because there's this dread of like, oh, there's so much work and like editing and then filming, and then like I know I'm not gonna make enough progress today, so like I just like might as well not make it. But you know, it's like every day you should make a little bit of progress, right? And that's what I've been trying to do with the stream, so just need to keep doing that. And again, it's about habits. Yeah, so just get into good habits, man. Okay, so hopefully tomorrow I'm gonna stream again, and we're actually gonna do like some performance profiling, because what I want to get better is like GPUs, but also I have some robotic stuff that I need to do, and I think if I can share it with you guys, I'll share it like this weekend. So yeah, I'll see you guys in the next stream.